Well, thank you, everyone. And yes, K4SQC used to always say for 30 years that it was a privilege to live in Atlanta in February. I had to get up at 4 a.m. this morning for a meeting with some people in Europe. And when I looked at the thermometer, it said it was 14. Um, and it made it all the way up to 22 today. So believe me, I'd rather right now be back down there with you all. But we did, in fact, move to be closer to kids. And yes, I changed my call sign. I changed back to the call I got as actually I was licensed in Seattle as a novice, KN7SYS. I changed to K7SYS for the same reason I changed to K4SQC. I really like doing QSO parties. And I discovered that doing the Georgia QSO party with a 7 call was really difficult because I was always explaining to people that I was in Georgia and it wasn't that I was trying to call Georgia. So having learned from that experience, I went ahead and changed back to things. At the present time, I am the Director of Operations for ARISS USA, and I thought we could walk through tonight a little bit about the radios over the years and what we had to do to get a new radio on board. This is the 20th anniversary of ARISS. We began shortly after the first long-term habitation on the ISS, specifically 11 days after the initial crew came on board that was full-time. We are NASA considers us to be an experiment, and we are the longest continuously running experiment on the ISS. We've had over 1,300 school contacts, and it's impacted lots and lots of kids. I know most recently in your neck of the woods, we did McConnell High School, and that was really a fun contact that was impacted by COVID. Unfortunately, all of them have been impacted by COVID now, but at least we figured out a way to make it still happen. Over the years, there's been lots of radios used on the ISS. And interestingly enough, almost all of them are still up there. We don't really use them and bring them back. They just go into storage. I say that somewhat. It is an interesting story. There was a contact today in the astronaut. One of the Shannon was asked, "What's the most difficult thing on the ISS?" And she said, "Well, one of the most difficult things we have to do up there is find things, because if we don't actually put them away, they just float off into space." And they get lodged behind things and around things. And so most of these are stored. We started out with an Ericsson, basically it's a 5-watt handy talkie prior to 2000. We also had a UHF handy talkie on 70 centimeters. 5 watts doesn't sound like much, but 5 watts from somewhere between 200 and 250 miles up is a pretty good antenna location. It actually works amazingly well. We got our first Kenwood D700 in 2003, and you'll see SM, that stands for service module. Basically, there are a number of modules on the ISS, and the ISS is basically divided into 2 segments. There's what's called the USOS segment, the United States Operating Segment, which is where that's basically NASA and ESA. And then there's another segment that's called the Russian segment, which is located, which is managed by the Russian Space Agency. In 2008, we had another D710 delivered after we had some programming issues with the first radio. And one of the things that has made this very challenging is when a radio breaks, you don't take it down to the bench and open it up and start looking at it, or you for sure don't go down to ham radio outlet and just buy a new one and install it. So we got another one up there. Along with in 2012 with another Ericsson handy talkie. The last was the radio we're currently on is a D710E, which replaced the D710, again with memory issues. One of the real challenges of operating a radio in space is the very much increased levels of radiation. And one of the things that tends to happen with these radios is if they take a cosmic ray hit in the wrong place, it can just really cause some problems. And as you can see, we've had memory issues pretty much right down the line. Kenwood has been very gracious about supporting us all along, and recently delivered in 2020, we got a D710GA that was delivered to the Columbus module, and that is the current radio, one of two current radios up there. We still have the 710E in the service module, and then there is the D710GA. So they're all 50 watt, 25, 50 watt class FM radios capable of at least 2 meters and 70 centimeters. So where are the radios located? This is a shot of the ISS. On the front here, this is considered the front. The direction of travel is this way. Just quickly, service module is back here. Columbus module is up here. These are the solar panels. These are actually heat radiators because they're handling heat in space is a real problem. Actually, it's been a problem for the radio. It's caused some issues because without gravity, there is no convection. In space, hot air does not rise. It just simply forms a cloud around the device generating the heat, and that cloud gets bigger and bigger. So there we are with the radios, and here's where the radios are. The Columbus module, the US operating segment, is up here. This is where the D710 GA is located. And back here is the service module where the 710E is located. So that's kind of externally, where are they? There's one antenna up here. There are actually multiple antennas back here that we use on both 2 and 440. So that's where the radios are from the outside. Now, from the inside, you thought your shack was a mess. This is the inside of the Columbus module. And I think the astronaut right now is engaged in some kind of a virtual reality activity. It looks like it to me because he's got the goggles on and he's doing some things with his hands. Some things to note about the ISS: since there is no up and down, equipment is simply placed on 3 walls. There's actually a little bit on the floor, for lack of a better term, although that is a little bit clearer so that people can grab onto things when they're toes, when they're floating around. Somewhere in all of this is a D710GA. Does anybody see it? Well, let's go to the next slide and give you a hint. Here it is, right up here. So whenever you're talking to the ISS, you're using the digipeater or the crossband repeater doing a school contact, that's where the radio is located that the astronaut is using. Yeah, I actually had my wife come in and look at this picture because she thinks I have too many wires hanging around in my ham shack. Kind of give her a frame of reference for how it could be. So how is it that we got to all of this? Well, as I said, the Ericsson VHF became really unreliable. For those of you who've been involved in school contacts, it's only a 10-minute pass, and they are extremely difficult to schedule. So we adopted which to the Ericsson handy talkie. It was for 5 watts output. We could only use it on telebridges because most of the school-built stations were not capable of supporting UHF. We then switched to the Kenwood in the service module, 50 watts output on 2 meters. Scheduling got complicated though, because since it was in the Russian segment, it had to be planned first through the US planning team, and then it had to be planned and coordinated through the Russian payload planning team. So it was just a very difficult road to to work. So we got to thinking, and actually been thinking for a while, that we really needed a new radio system. Kenwood had very generously donated 710 GAs with modifications. What kind of modifications did they make to them? Well, they modified them such that they could only run 25 watts. We didn't have to want to worry about the heat. Actually, they modified it so that in our version, not only can you listen on L-band on 12, actually 1267, but you can also transmit on L-band, which we intend to make some use of in the future. It's modified so that whatever mode it was in, it always returns to that mode. On and off, a number of items like that, just to make it easier for the astronauts, because we really want to make sure that they can do it in push a button format. The astronauts are scheduled in 5-minute blocks of time. They get about 5 minutes before a contact, the 10 minutes of the contact, and 5 minutes after to return things to normal mode. So it really needed to be done easily. New radios, and as I said, you don't just go down to a ham radio outlet and buy the power supply that goes with the Kenwood to make it work. For starters, there is no native AC power on it. More interesting, the Russian operating segment runs on 28 volts DC. The US operating segment runs on 120 volts DC. And so we needed a power supply that could convert either of those to the proper voltage for the radio. The other thing that what we have discovered, there was a time not that long ago when every now and then we'd have to shut the radio off. You know, the ISS has lived much longer than it was initially thought that it would. And one of the problems they're having, again, it looks a little bit like my ham shack, is they're running out of plugs. So that when we built the new power supply, we wanted to put the capability of multiple connections on it. This is actually something that's been thought about for a long time now. Back in 2010, they started thinking about ways to better support the amateur radio configuration. Here was the Ericssons, the antennas, pass-throughs, more about that. It turns out that pass-throughs through the hull of the ISS are a really big deal, and they are they're much sought after. By 2012, it had gotten a little more complicated. They were thinking about using an S-band beacon. There is a patch ASS that we have yet to use, but there is a patch antenna up there that we can use for things. There is, as you know, we had a ham radio system up there. It was functional for about 2 years. It had an S-band downlink on 2392 or 2395 gigahertz. And just when we were getting it rolling, I had my antenna up ready to receive. It died. And of course, the question was, what happened? It had to be what they called downmast. It had to be sent back down to Earth, then shipped to Kaiser Italia, the folks who built it. And it turns out that the modulator had failed. Again, I've never heard the final analysis of why the modulator failed, but some thought that radiation may have been involved again. That, as an aside, that radio has been fixed. It's ready for testing. It's kind of hung up in Italy, again, secondary to the situation with COVID, but we hope to get that back on the air here within the next year, which is really fun. And if anyone has any questions, we can talk about that if we have any extra time. So this is kind of where we're going as we're thinking about this interoperable radio system and what can we do with it, and how do we make it work, and how do we power it. 15, which is kind of where I started this, we actually started to power it. So we needed to convert 28 volts DC to 13.8 volts DC. We also needed to be able to convert 120 volts DC to 13 volts DC. And so this was kind of a early one. You'll notice that there are paths and the Russian segments so that everybody can use this, because one of the things over the years we've learned, it's really important wherever it is in the ISS when it comes to ham radios and the power supply is the same, so they can be used wherever they need to be used. So we started building things, and this is an example of one of the first prototypes that we built, and you'll notice that there's a red light on it. Well, little did we know that NASA does not use red lights. If a red light comes on anything on the ISS, it means drop everything you're doing and pay attention to whatever piece of equipment just had the light turn red. So it was a minor design piece, but we had to go back and take out all of the red lights and replace them with amber light. Here's a breadboard of that initial power supply. Kerry Banke and Lou McFadden and several others had a whole lot to do with building this. But this is what it looks like as a breadboard on the inside to get us to voltage regulation. All the types of things we needed to do, all the various control circuits to get things down to the appropriate level. There are a lot of different components. There are over 483 electrical components per unit. There are 11 different components. There are 9 custom circuit boards. We made 10 of these power supplies to go along with the 10 radios. You might ask, what do you need 10 radios for? Well, there's an engineering unit for the US. There's an engineering unit for the folks at the Russian Space Agency to work with. There are actually three flight units when they all get up there. Getting a space to get things up there is in itself an arduous process. And so what we're working for is to have 2 radios up there, one in production on the US segment, one in production on the Russian segment, and a third spare that can be swapped if we ever need to do that. These units have to be rigorously tested, and this is actually a shot from the Johnson Space Center. We had 2 guys down there for multiple periods of time, and one of the tests we had to pass was for electrical interference. This is the radio all set up in an echo-free chamber, and what we're looking for are any spurious emissions. All this white that you see is the cabling that's actually used up there, including the cable on the microphone cord. This is special NASA approved cord covering. What makes it different is it's not flammable. And so this was just an example of one of many tests. We had to pass a temperature test. There are certain temperatures that cannot be exceeded. We had to pass a sharp edge test. Is there any sharp edge on any of the equipment that someone might cut their finger on as they touch it? We had to pass a audio test, which was actually kind of a difficult one to test, to get past, since the fans on the power supply to keep it cool, the good news is you pass the heat and cold test. The bad news is maybe your fan gets a little too loud, and so there was some work that had to be done there to get that handled. So it really is a major issue to try and get all of the testing accomplished. And this is unit number 1 that you can see here. So here's the D710, and the white around the, I believe that's the PF3 button or PM3. That's the one that the astronauts are always trained to go to. Microphone with this special cable on it. The power supply, we ended up with 4 power supply outputs. On the side over here where you can't see it are some USB outputs to be able to handle USB things. This here was an additional thing we had to add after the heat testing. It's a fan to keep the unit cool, and this was actually developed by some students and 3D printed. And so this is an external cooling fan to help keep things too. Anybody recognize this? This is a Kenwood, what is it, VC10, I believe. It's their old slow scan unit that will do Robot 36, and it's still part of the system if we wanted to do it. It needed to be labeled. We actually labeled it twice because the first time we labeled it, the labeling didn't pass inspection, and so we had to label it again. You'll notice the guards around all the switches to make it more difficult to flick a switch on or off accidentally as you float by. But we finally got this all pulled together and we got it certified for load and stow on the SpaceX 20 launch. On the side of the power supply, for folks who it is interesting, we did list all of the folks who contributed significantly to the power supply. The one that caught my eye was Radio Disney, actually helped get this up there. And then these are all the folks that were involved in actually building the power supply. So we got it all put together. We got it down to Cape Canaveral, Cape Canaveral, and we got it loaded and put together for the SpaceX 20 launch on March 7th. Now, war story. If any of you ever get invited to watch a launch, and I was fortunate enough I did get to go, be sure you buy refundable tickets, because this is actually the second launch date. I got the pleasure of paying to go to Florida twice. And it really was far enough I didn't want to drive, but this really was a spectacular launch. This was the last launch of the Dragon supply capsule on a SpaceX Falcon rocket, and here it is at liftoff. The thing that, you know, the liftoff was interesting, and you could see the separation. The thing that really fascinated me was watching the booster return to land. You know, it goes through a sonic boom when it leaves, a sonic boom when it comes back, and to see that come down and actually land on the pad was a very interesting thing to observe. So we did get to orbit, and it was unpacked. You wonder how we got from March to September. Well, it turns out in NASA parlance, there's a difference between launch it and store it and then actually put it into production. But fortunately, in September 2020, Chris Cassidy installed the radio, stowed the old radio, initiated crossband repeater mode at 0102 UTC September 2nd, and that was the start of using the radio. So, how is the D710GA configured? For school contacts, we use either 2 meters or 70 centimeters at 25 watts. Again, primarily trying to be interested in heat conversion, heat conservation. The ARISS repeater runs 2 meters, 10 watts on 2 meters, and the crossband repeater as currently configured is 2 meters up, 70 centimeters down, and we're running 5 watts on that. We actually think we could run more, but again, you don't want to blow it up because it's a little difficult to get at it. There is an upgrade plan to go to L-band up and 2 meters down. We aren't quite sure how we'll do it. For those of you familiar with AMSAT, it'll probably be a little bit like one night will be experimenter's night, or however we do it to turn on the 23 centimeter things. Operating constraints. We do have some significant operating constraints. One of the things we struggled with a little bit is a lot of people, you know, they're used to working the satellites. Those can be controlled from the ground, so we can, you know, change modes fairly quickly. All changes at the present time require an astronaut intervention. As I said, astronaut time is very difficult to obtain. So therefore, all the mode changes are being tied to a school contact. In that 5 minutes after the contact, um, you can, that's when they can set the mode to the new mode, switch it from packet to crossband or crossband to packet, whichever way we need to go. There are some activities that require that the radio be shut down. All EVAs require a shutdown, particularly on the Russian side. The radios they use in for the EVAs are very close to the 2 meter band, and we certainly there. And again, some docking and undocking activities also require that the radio be shut down. So if there are occasions where you've been using the radio and then all of a sudden it isn't there anymore, invariably it's because something like this has gone on. Per safety protocols, we needed to turn the radio off. This is just an example of a schedule that an astronaut looks at and all the things that they're asked to do. I know people have been very disappointed that over the years there haven't been more random contacts made with the ISS. Christopher was the last astronaut who tended to make a fair of him. She loved to do that. I mean, she'd be drifting back to the Russian operating system for dinner, and she'd pick up the radio and say, "Hey, is anybody out there?" If she was in the right region. So this just it does make the point that it's just very difficult to get the time. Some folks wish we could change back and forth between packet and crossband repeater like once a week, and that's just really difficult to do. We are planning to upgrade the radio with to 23 centimeters. We need the antenna diplexer. That's actually being built and tested, and we'll get it flown and hooked up. There is a project in place using an ARISS Pi to actually start to automate some of these changes that the astronauts have to do right now. Some will never have total control because of that need to shut it down for EVAs, and it can't be that we're turning it off and they're turning it on, or vice versa. Expanded telemetry on it for the internal status of the ISS is one of the projects we're working on to allow students in particular to almost like they're in a mission control, looking at some of the internal telemetry again through the Raspberry Pi. And then we're hoping to be able to have some expanded ISS-based SST activities so that we can forward a file up and then have it show. One of the things that we've been looking at, because SSTV does seem to be very popular, is to allow qualified stations, and it's going to have to be a qualified station on a confidential frequency, to actually transmit SSTV images from the ground using the crossband repeater function. We think that could be a lot of fun, and it could allow us actually to have more SSTV events than we currently have. In terms of what are the recommended operating procedures with the new radio, always use the lowest power possible. We think, based upon some work we've done, that about 25 to 30 watts ERP is fully more than enough power. That's 5 watts into a 7 dB gain antenna. That's like a handy talkie into an Arrow. If you're using a 0 gain antenna, something like an egg beater, then you're going to need to run more power. But again, we really would like you to stay to the 25 to 30 watts ERP range. Always use full duplex. If you can't hear yourself, then don't transmit. Be kind and courteous to others. One of the things that maybe it's just because my ears are getting a little older, but some of the younger people like to really fast talk. And I think that actually leads to more repeats than if they talk just a little bit slower. You know, when I was in the Army, I used to watch some of the privates practice answering the phone, and they would say things like, 230th Medical Detachment, can I help you, sir? And it was just so fast, and it was like, what did they just say? So a suggestion would be slow it down just a little bit. Lastly, I would be remiss if I didn't say, please, if you can, give a donation to ARISS. These things, as you can see, are expensive. It takes a long time to do, and we need to be able to do that. And this was originally the end of my program. Oops. I guess I need to. Unfortunately, as you all know, on I believe it was the 27th, there was an EVA. What was the EVA all about? As I said previously, through-hull connectors are very cherished on the ISS. And the one we were using for our antenna actually had 4 RF ports through it. We were only using 1. Some other experiments needed to be done in that part of the ISS. And so during an EVA, a new cable was added. Our antenna was reconnected, leaving 3 more ports available for RF. Unfortunately, for reasons that are still under intense investigation, the radio is no longer connected to the antenna. We were wishing that there was a secret menu within the D710 that would allow us to check SWR. Unfortunately, that doesn't exist. So right now, we are back to using the radio, the D710E, and the service module while we work through with NASA, ESA, since the new project was actually a European Space Agency project, and Airbus to try and figure out what's going on with that new cable so that we can get the new radio that we worked so hard and so long for back on the air. And the time frame for that is not known, but when you're working with 2 space agencies and a commercial company, it's probably going to take a while to get this sorted out. Let me see here. I'm just reading the questions here. The fan, yeah, the fan is an issue. Does the ISS have internet access? The answer is yes, there's internet access through NASA, but NASA, because of security concerns, is really locked down right now. So I would imagine getting through the NASA firewall onto the net up to the ISS with DMR would be a really difficult thing to do if you wanted to use it in the normal fashion. Could there be a hotspot up there? That's a good question. I haven't heard discussions of that. As you can see from just the power supply, it takes a while to get things done working in that kind of an environment. Other questions?
I apologize if I missed it, but the antennas for the rigs, are they always facing Earth?
Um, it depends which antennas you're talking about. The antennas on the Columbus are general, if in a normal direction of travel, yes, they're facing Earth. We did some work because we were having some fades at time of closest approach when the ISS was as close to overhead as we thought it could be, and there were lots of explanations for that. One of it is the antenna is really just a quarter wave ground plane up there, and if you think about it, when you at time of closest approach, that antenna is pointed, that vertical antenna is pointed straight at the Earth. Where's the null on a vertical antenna? It's right off the end of the antenna. So that was one explanation. The other thing, we did some work, I don't know how they did it, but it's really pretty cool. It showed that in some orientations, as you're making the pass, one of the solar panels will swing between the antenna and the Earth. So again, that's we're having to transverse that structure. That's where the higher power, more than 5 watts, is helpful, particularly for the school contacts.
Well, I was asking because I was curious about, well, we all know about line of sight, but we get away with it down here because of reflections and such. But if it's on the other side of the craft, I'm wondering what would reflect it back into the.
Yeah, no, it is located such that it is always looking at it. If you've ever seen it, it's kind of interesting because what it really is, I mean, what it looks like, I'm not saying what it really is, but what it looks like is your standard tape measure antenna with a plastic coating over on it. And why is that? It's because they don't want an astronaut to trip over it on a spacewalk. So if they bump into it, it just bends and they go on and it springs right back again.
Thanks.
Bill, I see a hand up there. Other questions?
Joel has a question in the chat about radiation hardened radios.
Well, certainly if we had infinite amounts of money, we would buy the best radiation chips that we could find. Those are very expensive. And so we tend to buy, if we're building things, the best we can get. One of the things you don't see a lot of, at least in the amateur equipment, is very large scale integration. Because if you think about the downside of very large scale integration, when you can't buy just top dollar radio environments, that puts more and more stuff closer and closer together, which makes it a lot easier for a single hit to take out a significant amount of a system. Other questions?
Yeah, John.
Yes.
Kevin Scott, K4GTR. Do you happen to know K7SYS?
I know the name,
Okay.
but I don't know why I know the name.
Well, I used to work at Motorola in Boynton Beach, and Kai was from the plantation facility, and then I worked with him as well. I understand, and this is going from memory now, that the first ARISS contacts was actually with an MX300R that they had programmed and made it so it was a safe, that it could operate in that type of environment, because they had to go through all sorts of safety, and I forget what the certification is, but so it doesn't cause any flames or anything else.
Oh, yes.
And anyway, they actually, supposedly that was the first rig, amateur radio on the space station, and he was part of that, putting that whole system together. I think there was an article in QST magazine years ago where he had gone over that whole thing.
I focused primarily on the ISS itself.
Okay.
There was a whole nother experiments before that went on Mir, the Russian space lab.
Yeah.
And then there were a whole nother set of experiments that went on
Skylab. This was the ISS. According to that article, it was the ISS, but like I said, it was some temporary thing. It was a real kludge that they put together to make it work. But
Yeah, and I appreciate that. I appreciate that. And knowing what we had to go through to get the D710 certified, that must have been a real piece of effort. Yeah, flame is another one. That's why we have to put all these jackets on all the cables so that if they get hot, they don't burst into flames. Fire on the ISS is obviously a very bad thing to get started.
yeah, just to quote from the movie The Martian, it's like, and we need oxygen to stay alive.
Exactly. Other questions?
Thank you.
You're welcome. Other questions or comments?
Hey, John, this is Dave, W3DJS.
Hey, Dave.
We spoke before. Just wanted to throw an offer out there. I create a pretty well-known ham radio software distribution called HamPi. If you guys wanted to use it as a base for your ARISS Pi project, I'd be happy to work with you.
Yeah, send me an email. I'm good in QRZ. Send
Okay.
me an email and let's see what we can, because we're always looking for more people who know how to work with pies and how to make them do what they need to do.
Will do. Thanks.
Yep. Other questions or comments? Well, hearing none, I want to thank you for that. I hope that was interesting. I've had a couple people request from me, and I'll see if, well, actually, you have the presentation, the shack picture, so that they can use it the way I used it to say, wait a minute, you think my shack is messy? Look at this. It really is quite a thing. The way they attach a lot of that equipment, by the way, is with Velcro. Since it's weightless, it doesn't take a lot of things. Every now and then you'll see, if you're watching closely, if they want to take a picture, they have cameras just velcroed to the wall, and you'll see them just pull a camera off the wall, take a picture, and stick it back in the Velcro again when they're done with it.
I got a question.
Yes.
Is that snow on your face?
No, it's a insulator to keep my chin warm.
Okay. Good to see you.
Good to see you, Norm.
You probably need that in Idaho, Sean.
Yeah, well, I was saying that when I got up this morning, it was 14 degrees outside, and it's supposed to get colder than that tomorrow. So we'll see where we are.
Well, Dr. Kludt, it looks very distinguished.
Well, I have a good model to build after there.
Yeah, except mine's been like 40 years in the making.
Any other questions or comments? If not, thank you for having me. I hope this was educational and enjoyable. There's a lot going on up there. We do feel we're doing everything we can to get the crossband repeater back into operation again, because I know that's been a favorite. And when it's not in crossband repeat, it's going to be in APRS. So thank you, everyone. It's good to see you all again. I miss being in Georgia. Thanks now.
Thank you, John.
Thank you, John.
Everyone kind of give him the thank you. We appreciate that. Very good presentation, and good to hear about all the good things going on up there. And thanks to the whole organizations that keep all the work going and keep furthering that work. And we got to watch the telebridge from McConnell Middle. I know you were involved with that, but everyone did a fantastic job. We were all disappointed when McConnell couldn't make the contact direct, but using the telebridge worked out very, very well. And it even, David and I work with a young guy that just started with Gwinnett County. And I had it up on a big monitor and we were watching it. And since that time, I think that was one of the things that got him interested, and he just got his tech license just a few weeks ago.
Oh, that's good to hear. That's really great. Yeah, McConnell kind of led the way. I know that folks really wanted to do a direct, and quite frankly, we really wanted to do a direct. But then COVID-19 came along and just kind of put everything in the dumper. because you can't get large numbers of people together. So what McConnell did, what we've used repeatedly subsequently, we call a multi-point telebridge, and that's a way to have the contact but still be compliant with the COVID-19 regulations. We really hope, just as you all hope, that COVID-19 comes under control here shortly so we can get back to doing some direct contacts again.
It was, I have to say, it was the highlight in my amateur radio career when I got to establish the contact several years ago. I forget what school it was in, but I got to establish the I got to establish the contact, and it was just, I had one syllable to them, but it was so exciting. I really enjoyed it.
Well, John, I know you were involved in the one several years ago with Lanier Middle, I think it was, or is that the one you were referring to, Rick?
I think that was, yeah.
Yeah, Rick, it was Linear Middle, and it is exciting. I can also tell you, either way, when you're doing either direct, a telebridge, or a multi-point telebridge, from the chair I sit in, the time of maximum pucker is when that contact is trying to be established.
Yeah.
And all you hear is static coming
You're listening
back.
to the static. There's nothing else, and nothing else forever and ever, it seems.
It does seem like forever and ever. So that is certainly the time of maximum. Oh my gosh, is this going to work?
I
Right.
remember that one well, but I also remember you had a bunch of middle schoolers, and I think they may have invited some other schools in. You had that auditorium that was full.
Oh, yeah.
And when the astronaut came back, I know the first one we called for NA1SS. They didn't come back on the first one. On the second one, they came in, and you saw all these middle schoolers. It was like you could have dropped a pin in the room and heard it. And they just, their mouths wide open.
Yeah.
In a day of smartphones and texting and everything else, that was something that really caught their attention.
Yep.
And it was a great teacher there as the sponsor. So that was great.
Yep, those are good times. Good times indeed.
I'd thank everyone involved for my participation in that.